So now we are going to discuss file permissions, user and group administration as well. So let's start off by creating a user. We will create Karen, alright, and we'll create another user here in just a moment. Now grep for Karen in the etc password file, and we can see that a home directory is created for Karen /home/Karen, and she gets the shell bin bash. She has the user ID 501 and the group ID 502. Grep Karen, we'll just cat the etc group file, and we will see that a group was made for Karen called Karen. So Karen, the user, was created, and the group Karen was created, and Karen's primary group is the group Karen. Now, where do all of these things come from? Home, Karen, bin, bash, all that stuff, right? Well, we have a file called etc login.defs. So this is login defaults, and the parameters in this file control some of the stuff that happens when a user is created. So it says create the home directory, yes. User groups enabled, yes. We also have another file called etc defaults user add, etc default user add. And if we look at that, this is the defaults file. Home is the home directory. Their default shell is the bin bash, and there's the etc skell directory, and I'll explain that right now. So when I created the user Karen, if I do an ls-a/home/Karen, that home directory was created. And if I list the files, these hidden files are thrown into there, right? And kind of sets up Karen's environment when she logs in. Those files are copied from etc skell, okay? And if I do an ls-la/home/Karen, we'll see that Karen, the user, owns them, and Karen, the group, owns them, right? So those are copied from etc skell, and they are the default files. I'll just touch file 1 in /etc/skell, ls-la, etc skell, and we'll see that oh, whoops, I created file 1 here. So yeah, touch /etc/skell/file 1, and created a file in there. Now, we're going to add the user Frank. So I say user add, and I say -c, and I say Frank, nobody. Frank White, we'll call him Frank White, and he is an accountant. An accountant and Frank. Now, if I grep Frank in the etc password file, we will see that the comment field here is what I put in right here. And here's his home directory, and here's his shell, and these are the shells on the system. So maybe Julie, she likes the bin, she likes C shell. So I can say user add -s/bin/csh Julie. And now if I grep for Julie in the etc password file, I'll see that she has the bin, she has C shell. And if I say I can modify users that are created, and I want to add a comment field to her, user mod -c, and I'll say Julie Bloom, and she's also an accountant, and I say Julie, right? And I can also say modify her shell. Julie now decided that she likes bash/bin/bash Julie, grep for Julie, and now she's using bin bash bash. She's using her shell as bash. Okay, now user del Julie. So I deleted the user Julie, but if I do an ls-l/home, I will see that her directory is still there, and it has numbers here, right? So I'm gonna have to rm-rf/home/Julie, right? Well, if I do a user del-r Julie, that would remove her home directory when it deletes her from the system. Okay, so created some users, right? I got Frank and I've got Karen. So I'll explain SU here in a minute, but basically I'm changing my user to Karen, and come over here and open a tab, and I'll change my user to Frank, right? Now, I create a file in here, and I'll call it file1. And, hi Frank, how you been? Sincerely, Karen. Okay? And Frank's like, Karen says to Frank, I wrote you a letter. It's in my home directory. It's called file1. Frank's like, oh, I'm going to look at that, man. So he's like, yeah, I want to look at this file. File1. Oh, man, permission is denied. Can't read the letter. She even put in there, how you been? I really like you. There we go. But Frank's in the dark, and Karen comes into work, and Frank acts like nothing, and she feels rejected, and everything just goes wrong because of file permissions. Now, if I look at file1, I will see that this file is owned by the user Karen. Everyone in the group Karen has access to the file. Well, everyone in the group Karen has permissions to the file, and everyone else on the system has permissions to the file. These bits say the permissions. So the user Karen has read-write access, everyone in the group Karen has read-write access, and everyone else on the system, all other people, have read access. Now, root, okay, the system administrator is like, I wonder what Karen's trying to say to Frank. Home Karen file1. Oh, that's hilarious. How cute. Root can access any file. They are superpower, super user. Super user. So they can access any file. Okay. So why can't Frank access this file? Because everyone else on the system has read access to the file, so Frank should have read access to the file, right? ls-ld/home/Karen, and we will see that Karen, the user, owns the file, or the directory. Karen, the group, owns the directory, and these are the permissions. Karen, the user, can read, write, and execute on the directory. Karen group members have no access to the directory, and all other users have no access to the directory, right? So Frank really wants to access the file. He comes in and he says, Karen, hey, I don't know what's going on. I don't know what was in that file, but, I didn't get to see it because I got a permission denied. Oh, okay, Karen feels a little bit better now, and I'm going to open something up real quick. Probably like, what am I doing? I'm going to open up basically like a little notepad window here. And, okay, so Karen's like, oh, you know what? You don't have access to my directory. So she comes over here and she does chmod and 7 and 55 home Karen, right? Karen owns that directory, so she can do things with it, and she can change things on it. So she gives her, she still has read, write, execute. Everyone in the Karen group has read, execute, and everyone else has read, execute. Come back over to Frank and, oh, hi Frank, how you been? I really like you. Sincerely, Karen. Oh, Frank's like, yeah, that's awesome. I'm gonna add to this letter, and and Karen, I like you too. Okay, right? Oh, can't write to the file. Frank doesn't have write access. First off, he doesn't have write access to any files in the directory. Second off, he doesn't even have write access to the file. If I chmod 666 file 1 and give him write access, now he can write to it. Okay, so here's the thing, right? In order to access a directory, the execute bit and the read bit have to be set. Okay? The files in the directory, now you can access the directory, and now the files have their own permissions. Okay? But if the read and execute bit are not set, and it seems strange, why the execute bit on a directory? This gets pretty funky, but check this out. So if we chmod this directory, and I'm going to explain chmod in just a second, to 744 Karen, right? And I do an ls-l. What am I doing? Why did I do 244? 722. What in the... Oh, I'm... Yeah. It would be 744. Ah, did I do 722? I did. 744. Gosh. Okay. So now I have read and read. So Frank has read access to the directory. So ls/home/Karen. Can't access file 1, permission denied. I can check it out. I can list the contents of the directory, but I can't actually access the file. So home. So let's try and cat this. Home Karen file 1. Can't. Permission is denied. With read access, I can only list the contents. I can't actually, open files, look at files, stuff like that. So you have to have execute access to be able to, open files, look at files, and whatnot. Now, 755, what exactly does that do? 1 is the execute bit. 2 is the write bit, and 4 is the read bit. Okay? So 755, 7, this chmod 755, let's say a file or a directory, that'll set, this first bit sets for the user owner, in this case Karen. 4 plus 2 plus 1 is 7. So it sets read, write, execute. For the group, it gives them read and execute, Rx. For everyone else, it gives them read and execute. Okay? If I wanted to say just read, I could do that. If I wanted to say write and execute, I could do 3. If I wanted to say all, I'd do 7. If I wanted to do write and read, I could do 6. So whatever permission you want to set, add these up, and that's how you do it. Chmod 7, and the first bit's user, second bit's group, third bit is everyone else, right? So 7 is 4 plus 2 plus 1, 5 is 4 plus 1, 6 is 4 plus 2. So read, write, execute, read, execute, read, write, right? Okay. There's another way to do this, and I don't particularly do this very often, but I could say chmod u plus rwx, file or directory, and that gives the user read, write, execute permission on the file. So whoever owns the file, that gives them read, write, execute. If I were to do chmod, so I can do chmod G rwx file or directory, and that gives the group rwx permissions, and chmod O rwx file or directory, that gives everyone else rwx permissions. Okay, I can combine these and say user rw x and group. I'll say rx and others rx and rw, let's say, file or directory, right? So that gives the user read, write, execute. That gives everyone in the group read and execute, and that gives everyone else read and write. If I were to do, say, this, chmod plus rwx file or directory, that is the same thing as doing chmod a rwx file or directory. What does this do? It gives everyone, so not everyone else, everyone on the system, the user owner, the group, and everyone else on the system, rwx access. If I don't specify, say, user or group or other here, and I just do plus, that's the same as giving everyone rwx. Okay, I can do chmod user plus rwx group and other equals rw file or directory. That gives user rwx, and group and others, it gives them read, write, right? So read, write, and execute. That is another way to do it. I personally always go with the bits. I don't know why. That's easier for me to remember. Maybe I've been doing it for so long. If I want to take away, I do chmod group minus rw file or directory. That'll take away read, write access, read, write permissions on the file or directory for anyone in the group, you know. So, you know, just replace the plus with minus here, and that will take things away from them, right? Now, there's one other thing I failed to mention here. When I am doing, let's say, chmod 756, as I did above, file or directory, right? And what would that do? That would be, for the user owner, that would be read, write, execute. For the group owner, that would be read and execute. For everyone else, that would be read and write. So let's do it. Chmod 756 file 1 ls-l. I say, it says 756 is read, write, execute, right? 7. 5 is 4 plus 1, and 4 is read and 1 is execute. So that's for anyone in the Karen group, and everyone else has read, write access on the file, right? What I'm effectively doing there when I type that in is I'm actually typing in 0756, because there's another bit here, okay? So this is another thing. Okay. Let me show you what that does. If I put 4755 on this file, and then I do an ls-l, notice the color changed, and notice that the execute bit here in the user permissions has changed to an S. What does that mean? Well, let's take a look at user bin password. Sorry. Okay, password. It also has this S, right? What does that mean? Well, root owns this file. The root user owns this command, the password command. And what this means is that any user on the system can effectively run this command, password command, as root. Okay? It's called setuid bit. And when I type in password, I'm running the command as root. Why? Let's look at Etsy password. I don't have write access to it. And let's look at Etsy shadow. I don't have any access to it. Okay? So what I need to do is this command writes to this file here, and basically I need to be able to write to that file, so I have to run this command, and it has to be run as root because I have to be able to change my own password. I'm Karen, I'm changing my password, right? Now, let's say I try and change the password for Frank. It's going to say, oh, you can't do that, only root can specify a username. So I come over here, I open a tab, and I say password Frank, and I am root now, and I can change the password. But, you see, when I'm Karen and I run the password command, I'm running it as root. The check to make sure, that I'm only changing my password is not in the command. There's a security measure in place that we'll cover later that says, hey, if I'm specifying a username and I'm not root, don't allow that to happen. But this setUID bit, signified by the 4 right here, in this field right here, will basically allow any user on the system to who has access to run the command as the owner of the command. So this file 1, if this was a command, any user on the system could run this command as Karen. Okay, if I did it this way, then not every user on the system could run the command as Karen, but anyone in the group Karen could run the command as Karen. Okay, because all of their users don't have execute permission. Okay, there's another thing that this bit does. I'll go over this one real quick, the sticky bit. Okay, if we look at the temp directory, if we look at the temp directory, we'll see there's a T here. That's the sticky bit. To get the sticky bit, 1777/temp, right? The 1 here says it's a sticky bit, okay? The sticky bit, if it's set on a directory, it prevents users from renaming or deleting files in the directory unless they are the owner of the directory, which in this case is root, or the owner of the file that they're trying to delete, or root can basically override that as well. Sticky bit, personally, haven't found a lot of use for it, but there's definitely use for it. So I mean, it's still in use on the temp directory, because a lot of people have write access to the directory, read access to the directory, execute access to the directory. But if that wasn't set, I could delete any file in the directory. But since that's set, I can only delete my own files. Now, we've got the set GID bit. That's the final bit. Okay? This is useful. Let's say I have got a group of programmers, right? And I say make directory /home/programmers. Okay? And I want these programmers, they're going to work together, they're going to collaborate in this directory home programmers, right? So I add, user add, comment field, Jim Beam, programmer, and I say his home directory is /home/programmers, so it doesn't create /home/Jim, it's going to set his home directory as /home/programmers. And I say his group is programmers, and his username is Jim. My bad. Group add programmers, and tell this one /Etsy/group, and I can see that I now have in my Etsy group file a group called programmers, right? Okay, now run that user add again. There we go. So it added Jim. with the secondary group programmers, his primary group is still Jim, and his home directory is /home/programmers. And his comment is Jim Beam, and he's a programmer, right? Let's add another one, name him John. We'll call him John Vanderloo. Okay, and he's a programmer. And Kate, we'll name her Kate Floss, and she's a programmer. Okay, so we got these 3 programmers. They're working in this directory. Notice it says user add warning. The home directory already exists. Not copying any files from the Skell directory into it. I can copy the files over myself. Copy -r for recursive etc skell dot, saying copy hidden files as well, /home/programmers. Do an ls-la on home programmers, and we've got that right there. So when Kate logs in, her environment will be set, and her home directory is home programmers, right? Do an ID. Her primary group is Kate. She is also in the secondary group programmers, right? Let's say I wanted Kate to be part of the group, I don't know, VBox users, I think is a group. VBox users /etc/group. Okay, so I got this group VBox users, right? And I want Kate to be part of that group. User mod -g for secondary groups, VBox users. You know, user can be a part of as many groups as you want to put them in. So I want to make her a member of VBox users, Kate. Now, if I hit enter right now, it's going to take her out of programmers and put her in VBox users. So whenever you do this, a user mod, and you're going to add a person to a secondary group, and you want to keep their existing groups, do a -a. So that will keep their existing groups and add them to this group. If I got rid of the -a, it would just add them to this group and take her out of the programmers group. So I'll do -a, grep Kate in the etc group file, and we'll see that there's a group called Kate. That's her primary group. Group called programmers. If there's people over here or their usernames over here, these are secondary members of the group, and she's in this group as well. Come back over here, ID, exit, SU back to her, ID, and now it shows me as VBox users programmers. Okay, so she's in that group now. That's just showing you how to add secondary groups. Okay, so home/programmers, and we've got Jim, John, and Kate. So I'll SU to Jim. And I'll create a file in here. Let's call it file Hey Kate. I'll call it Hey Kate. Okay? Throw some text in here. Hey Kate, please do all my work for me. I don't like it. Sincerely, whatever the heck my name is, right? Can't open file for writing. Can't open file for writing, right? Alright. So, come over here to root. Log out of Frank. Come over here, be root. ls-ld/home/programmers. Well, I was root when I created it. So it's owned by root, and it is, the group owner is root. So let's change the ownership of this. This is another aspect of permissions. Remember, we have a user owner and a group owner. If I want to change the group, I can, well, let's change the user. Let's make the user that owns this Frank for some reason. Frank the accountant owns home programmers. Now, take a look, and Frank the user owns it, and anyone in the root group owns it as well, has access to it, has these permissions to it, right? Okay. Now I want to say Frank the group owns it, chown .frank /home/programmers, and do that, and now Frank the user owns it and Frank the group owns it. So if I wanted to change the user, I would just do chown the username and then home programmers. If I want to change the group, chown dot and then the group name home programmers. That changes that. If I want to change both, which I want to do, I want to change it to nobody. There's a user on the system called nobody. It's not really a user, it's kind of a special thing. I'm basically saying nobody on the system owns this. So changing it to nobody user and the group programmers /home/programmers. So this is combined. So user dot group, chown user dot group, and then the directory or the file. You can change file ownership as well. And so, okay. And still, the group does not have write permission to the directory. ls-ld /home/programmers. Only the user does. So chmod that and say 775 /home/programmers, right? ls-ld /home/programmers, and there we go. Okay, come in here and vi this file again. Hey Kate, please do all my work for me. John. I think my name was John. My username is John. Jim, whatever. I go by John. So now I'm Kate, and I see this file in here called Hey Kate. So I vi it, Hey Kate, and I say, Hey John, forget it. And I write it, and it says, it's read-only. What? Alright. So let's look at the permissions here. The file, Hey Kate, is owned by Jim, the user, and it's owned by Jim, the group. So Kate has read permissions because she's neither the user Jim nor is she in the group Jim. She has read permission to the file. That is not exactly a shared directory. So let's make it a shared directory. Let me first remove this file I seem to own in there as root. Okay. So now chmod 2. This is the SGID bit. Okay? 2775 /home. We'll say 770 actually. Actually, we'll say 0. Yeah, 070. Yeah. /home/programmers. Okay? Now, take a look at home programmers, and nobody has any permission on it, meaning the user owner, who is nobody, has no permissions. The group programmers has read, write, and there's the sticky bit, or not sticky, the SGID bit, setGID bit. Okay, and everybody else has no permissions on it. So if I try and, as Karen, I try and do an ls/home/programmers, it's going to tell me permission denied. Now, I'm Jim, right? And when I created the file earlier, before that SGID bit was there, it created it as Jim, right? So remove Hey Kate, and let's create it again. vi Hey Kate. Hey Kate, how you doing? Okay, do an ls-l, and Jim, I own it still, but programmers, the group, owns it, and they have read-write permission to the file. So now as Kate, I come over here and I VI hey Kate, and I say, I'm doing just fine. Save it. Take a look at his Jim, and say, oh, that's great. She updated the file. Now, all members of the group programmers, okay, can access, create files in this directory, can modify files. They all share these files. So if the setGID bit is set on a directory, files created within the directory will be given group ownership of the directory. Or not the directory, group ownership of the file. So as well, actually, a directory, if I create a directory and I take a look at it, the directory also gets group ownership. So that is how you create a shared group, and that is the setGID bit. Remember we did, so chmod 2755 file / directory setuid, which means run command as user owner. Chmod 4, oh whoops, setuid is 4. 2 is setGID. Sorry, I got setGID on my mind. 2775 file directory setGID, files created in files and directories created in directory owned by group, and then chmod 1777's directory. This doesn't apply to files really at all, is the sticky bit, right? And the sticky bit says basically that, you know, only file owner, file or directory owner, or root can delete the file or directory within the directory with sticky bit. That's probably a really convoluted, terrible way to put it, but okay. Now, because I showed you how to do these permissions, this is how you do the sticky bits, or the SUID. So this is a SUID file. So if I want to say user bin password, set UID on password. Chmod G+S directory, set GID on directory, and chmod +T directory, set or sticky bit, set sticky bit on directory. Okay, so come back over here and we'll get back on Karen and Frank. Okay, actually we'll just do this with root and Karen. Okay, so root and Karen. Got a couple other things we want to look at here. Remove file 1 from Karen's directory and say ls, and I've got nothing in here, and I touch file 1, and I come over here as root, clear, and I remove file 1 if file 1 exists. It doesn't, so I touch file 1. So I just touch file 1 in the root directory as root, and I touch file 1 in Karen's home directory as Karen, right? Now, look at the permissions on this file. This is Karen. Look at the permissions on this one. Okay, and this is root. So, the file is created with read-write for Karen, read-write for Karen group, and read for everyone else. This file is created with read-write for root, read for root group, and read for everyone else. Okay, those two are different, and why? And what determines the permissions on these files? Okay, let's do another thing. Make directory, directory1, ls-ld, directory1, make directory, directory1, ls-ld, directory1. Alright, come back over here to Karen. The directory is created with read, write, execute for Karen, read, write, execute for Karen group, read, execute for everyone else. For root, the directory is created with read, write, execute for root, read, execute for the root group, and read, execute for everyone else. So let's go over something really quick. Okay? So let me grab this, and we'll say, what? Oh, whoops. Let me grab this output here. Okay. We'll say root. Okay. And we'll say Karen. Grab this output from Karen. Okay. And so that's Karen. Okay? So this is the file we created as Karen. This is the file we created as root. These are the permissions. As we can see, they're different. Okay? Type in umask as Karen, umask, and I'm used to just highlighting it and it copies it. Umask of 0002, and type in umask as root, and we get 0022. Okay? So what exactly does this mean? Let me show you. Okay. Okay. So the umask determines what permissions directories and files are created with. Okay? So files cannot be created with, this is a security measure, with execute. Okay? So when I create a new file, I say touch file 1, right? It's not going to get an execute bit. That's a security measure. You don't want that to happen. You only want to determine whether or not the file is going to be executable, and you would do that with chmod, right? So I create a file, and those are the permissions, right? Now, to get the permissions that the file will get, we take that and we minus Karen's umask is 0022. So we'll do Karen first. And that is 0. 6 minus 0 is 6. 6 minus 0 is 6. 6 minus 2 is 4. Okay, that's files for Karen. A directory for Karen. Directories do get the execute bit. 0002 is going to be 0775. Okay, so the umask drives this. It determines what the default permissions are going to be. You end up with this, and this is read write, read write, read. This is read write execute, read write execute, read execute, right? Do the same thing up here. Our umask was a little bit different on root, right? 0022, so we say for files is 0666 minus 0022 equals 0644, which is read write for root, 4 is read for the root group, and 4 is read for everyone else. 0777 minus 0022 is 0755, which ends up being read write execute for root, read execute for root group, and read execute for everyone else, right? So the directory starts with 777 or 0777 and minus the umask, and you get the permissions that the directory is created with. The umask drives this. Files 0666 minus the umask, and you get what the files are created with. And so root and the user Karen have, different UMasks. Now, if I came over here and said Karen's got a UMask of 0444, right? And I type in UMask, and I type in touch file 2, and I do ls-ld file star. Now, with the UMask of 444, the file gets created and it has write for everyone. Okay, why? Well, if we look at the file and the UMask, 0666 minus 0444 equals 0222. 2 is write. Remember? 2, write. Right? So 666 for files minus UMask equals the default permissions. The permissions that will, when a file is created, what it'll be. 777 minus UMask equals default directory permissions. And that's how that's driven. Now, typing in UMask 0444, right? And I type in UMask and it says, oh, that's my UMask now. Typing it in like that is not a persistent thing. So when I exit and I SU back to Karen, log back in as Karen basically, and I type in UMask, my UMask is set back to 0002. I can make the UMask a persistent thing, but I'm not going to do that right now. So doing the UMask command, as soon as you log out, the UMask is gone. Alright, so let's go back over here to Jim and Kate. Let's say that Jim is the group, he is the programmer lead, okay? So let's do a user mod on Jim. User mod -c Jim, well, grep Jim in the Etsy password. What do I have him as? User mod -c Jim Beam programmer group lead. Alright, just changing the comment field for Jim. So Jim is a group lead for the programmers, okay? So now we want Jim to have access to the group programmers, right? The actual group on the system programmers. So if Jim, let's say I had a user add George. Is there a George? No. Okay, so I add the user George, and Jim's like, George is a programmer. I want to put him in my group. -g programmers George. Permission denied. Jim cannot do that. So what we can do is we set gpassword. Gpassword programmers, and we set a password on the group, right? And then we do gpassword -a Jim as root, and that makes Jim -a programmers Jim. Jim -a Jim programmers, man. And that makes Jim an administrator of the group programmers. So now, if we grep programmers in Etsy group, we'll see that Jim, John, and Kate are members. So now I come over here as Jim and I type in gpassword -a George programmers. Adding user George to group programmers. Now I grep him, and George now has the group programmers. He's now a member of that group. So that gives Jim permission to basically be the administrator of a group. So And Jim can delete George. George, get out of my group. And George is no longer a member of the group programmers, right? um, let's see. So that gives that. Now, I've been doing a lot of this. SU space dash Jim, right? Assume user, become that user. That's what that means. What's the dash mean, though? The dash basically means take on Jim's environment, all of his environment variables, right? So if I do that and I echo my path, I see that at the end of my path there's my home directory, home/programmers/bin, right? That's my environment variable path. If I leave out the dash and I echo my path, I've still got my path as root/bin. I've still kept some remnants of my own environment. Okay, so when I su to a user, I do su dash alone will su to root. If I did su alone, it would su to root, but I wouldn't take on the root environment. Su dash takes on the root environment. Su Jim does not take on Jim's environment. Su space dash Jim does take on Jim's environment, right? So as Jim, su space dash Jim, I type in ls/root, and it says permission is denied. I can actually, instead of just suing to the user, I can do su space dash c, and then single quote ls/root, and run that, and type in my password, and I get a listing, or actually I'm not typing in my password, I'm typing in root password. I run the command as root. Okay? If I try and do ls/home/Karen, I can do that. What if, can I do /home/programmers? Oh yeah. What are my permissions on Karen? Alright, let's try and do ls/home/Jim. /home/Frank. I can't do it. Permission is denied. su space dash c ls/home/Frank, and then Frank. Type in Frank's password. Password Frank. Let me set a password on him. Password Frank. Set a password on Frank. And now I can ls. I'm running this command as Frank, and I can, view the contents of that directory. There's another command we'll get into. It's called sudo, and I'll probably go over that in. We're going to go over different things in the security video, such as, for example, let's say right now I have 3 bits here. I have the user Karen, the group Karen, and everyone else. Now let's say Frank is obviously not the user Karen, and Frank is not in the group Karen, but I want to give Frank access to this file without giving everyone else access. We can do fine-grained access like that using access control lists, and I'm going to get into that in the security video, along with IP tables and sudo and different things like that. So at this point, I think we are actually done, and the next video is processes on the system and run levels and how the system starts up. So looking forward to seeing you in that video.